Hello my lovely students, you're welcome to a new lesson. Today I shall be teaching you mensuration of compound solids and frustum. From definition, compound or composite solids are made by joining basic solids together. For example, two cylinders, two cuboids, and so on. An example of a compound or composite solid around us is a building, which is made up of a triangular prism and a rectangular prism joined together. Next, let's learn how to calculate the surface area of a compound solid. In our first example, Daniel built a birdhouse. What was the surface area of the birdhouse before a hole was drilled? In the diagram displayed here, the birdhouse is a compound solid made up of a triangular prism and a rectangular prism or a cuboid joined together. The triangular prism has two triangular faces and two rectangular faces, while the cuboid has 5 rectangular faces. To calculate the area of the triangular prism, let's first of all calculate the area of the two triangular faces. The formula is 2 times half base times height. The base of the triangular faces is 30 centimeters and the height is 8 centimeters. From calculation, the area of the two triangular faces is 240 centimeters squared. Next, let's calculate the area of the two rectangular faces of the triangular prism, which is 2 times length times breadth. The length is 24 centimeters and the breadth is 17 centimeters. From calculation, the area of the two rectangular faces is 816 centimeters squared. When we add these areas together, the area of the roof, which is a triangular prism, is 1056 centimeters squared. Next, let's find the area of the rectangular prism, which is a cuboid. It is made up of 4 rectangular walls and the bottom area. 2 of the walls have dimensions 18 centimeters by 24 centimeters. Multiplying 2 times 18 centimeters times 24 centimeters gives 864 centimeters squared. The other 2 walls have dimensions 18 centimeters by 30 centimeters. That will give a combined area of 1080 centimeters squared. The area of the bottom is 30 centimeters times 24 centimeters, which is 720 centimeters squared. Adding these areas together, the area of the rectangular prism is 2664 centimeters squared. Finally, the surface area of the birdhouse is the area of the triangular prism, which is 1056 centimeters squared, plus the area of the rectangular prism, which is 2664 centimeters squared, which becomes 3720 centimeters squared. In our next example, let's calculate the surface area of the compound solid shown here. The compound solid is made up of a cone and a cylinder joined together. The perpendicular height of the cone is 4 centimeters, the height of the cylinder is 8 centimeters, and the radius is 3 centimeters. The formula for the curved surface area of a cone is pi times the radius times the slant height. Using Pythagoras theorem to calculate the slant height of the cone, the square of the slant height, L squared, is equal to the square of the perpendicular height, 4 squared, plus the square of the radius, 3 squared. From calculation, the slant height of the cone is 5 centimeters. The surface area of the compound solid is equal to the curved surface area of the cone plus the curved surface area of the cylinder plus the area of the bottom circle. The curved surface area of the cone is pi arrow L. The area of the bottom circle is pi radius squared. And the curved surface area of the cylinder is 2 pi radius height. When you calculate these areas and you add them together, the surface area of the compound solid is 226.29 centimeters squared. I hope this solution is clear to you. Next, let's learn how to calculate the volume of a compound solid. Find the volume of the compound solid displayed here. The compound solid is made up of a triangular prism and a rectangular prism, or a cuboid. The triangular prism has dimensions 4 cm wide, 4 cm high, and 6 cm long. While the cuboid has dimensions 6 cm wide, 4 cm high, and 12 cm long. The volume of the compound solid is equal to the volume of the triangular prism plus the volume of the cuboid. The volume of the triangular prism is the cross-sectional area times the length. This is equal to half times the base times the height times the length of the triangular prism. From calculation, the volume of the triangular prism is 48 centimeters cube. The volume of the cuboid is length times breadth times height. From calculation, the volume of the cuboid is 312 centimeters cube. Finally, the volume of the compound solid is the volume of the triangular prism plus the volume of the cuboid, which is 48 centimeters cube plus 312 centimeters cube. The volume of the compound solid is 360 centimeters cube. In our next example, let's find the volume of the compound solid displayed here. The compound solid is made up of a cube of side 6 centimeters, having a hole in the form of a cone drilled at the top. The base diameter of the cone is 4 centimeters, while the perpendicular height of the cone is 6 centimeters. Hence, the compound solid is a hollow solid. The volume of the hollow compound solid is the volume of the cube minus the volume of the cone. The volume of the cube is the length of the side raised to power 3, while the volume of the cone is 1/3 times pi radius squared height. The base radius of the cone is half of the base diameter, which is 2 centimeters. When you substitute your values into the formula and you calculate, the volume of the hollow compound solid is 190.86 centimeters cube. Next, let's learn about the frustum of a cone and a pyramid. From definition, a frustum is made by cutting a cone or a pyramid through a plane parallel to the base. An example of the frustum of a cone is a bucket, while an example of the frustum of a pyramid is the hopper of a pepper grinding machine. Here is the diagram of the frustum of a cone, which is a truncated cone, and the diagram of the frustum of a pyramid, which is a truncated pyramid. The frustum of a cone has a big circular surface, a small circular surface, and a curved surface area. The radius of the big circular surface is big letter R. The radius of the small circular surface is small letter r. The perpendicular height is h, while the slant height is L. Here are the formulas for the curved surface area and the total surface area of the frustum of a cone. Please take note of these formulas. Here is the formula for the volume of the frustum of a cone. Once again, please take note of this formula. In our next example, a bucket is in the form of a frustum of a cone. Its depth is 30 centimeters and its top and bottom radii are 36 centimeters and 32 centimeters respectively. Find the volume of the frustum. From the solution, the volume of the frustum of a cone is pi times the perpendicular height divided by 3, multiplying the small radius squared plus the big radius squared plus the small radius times the big radius. That will give 22 divided by 7 times 30 centimeters divided by 3, multiplying 32 centimeters squared plus 36 centimeters squared plus 32 centimeters times 36 centimeters. From calculation, the volume of the bucket, which is the frustum of a cone, is 109,120 centimeters cube. In our next example, let's calculate the surface area of the frustum of the cone displayed here. The small radius is 7 centimeters, the big radius is 13 centimeters, while the perpendicular height is 8 centimeters. From the solution, the formula for the surface area of the frustum of a cone is pi into the small radius squared plus the big radius squared plus the big radius plus the small radius times the square root of the perpendicular height squared plus the big radius minus the small radius squared. When you substitute your values into this formula and you calculate, the surface area of the frustum of the cone is 1313.71 centimeters squared. The frustum of a square-based pyramid has a small square surface at the top, a big square surface at the bottom, and 4 trapezium surfaces around it. The side of the small square is A, the side of the big square is B, the slant height is L, while the perpendicular height is H. Here are the formulas for the total surface area and the volume of the frustum of a square-based pyramid. Please take note of these formulas. In our final example, a frustum of a pyramid is 16 centimeters square at the bottom, 6 centimeters square at the top, and 12 centimeters high. Find the volume of the frustum. From the solution, the volume of the frustum of a square-based pyramid is 1/3h into a squared plus b squared plus ab. Here, h is 12 centimeters representing the perpendicular height, a is 6 centimeters representing the side of the small square, while b is 16 centimeters representing the side of the big square. When you substitute your values into the formula and you calculate, the volume of the frustum of the square-based pyramid is 1,552 centimeters cube. I hope all these solutions are clear to you. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic, mensuration of compound solids and frustum, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.